Modern engines require fundamentally different maintenance approaches compared to older models. Understanding these differences is crucial for optimal performance and longevity. Traditional engines from the 1990s had simple systems with basic sensors and relied on fixed maintenance schedules. Modern engines feature complex systems with smart sensors that require adaptive maintenance approaches. The key principle is quality over frequency. Instead of using cheap oil every 3,000 miles, modern engines benefit from premium oil that lasts 7,500 miles or more, resulting in lower total costs. Oil analysis provides scientific data about metal content, viscosity breakdown, contamination levels, and additive depletion. This data-driven approach can extend oil life by 50 to 100% while predicting failures early and reducing costs. Predictive maintenance represents the future of engine care. Unlike traditional run-to-failure or scheduled maintenance, predictive maintenance uses real-time sensor data to determine exactly when service is needed. Internet of Things sensors continuously monitor oil condition, engine temperature, vibration patterns, and performance metrics. Machine learning algorithms analyze this data to predict component failures 1,000 to 5,000 miles in advance. Preventive maintenance delivers exceptional return on investment. Every dollar spent on preventive care saves $4 to $7 in reactive repairs, making it the most cost-effective approach to engine maintenance. Understanding modern engine maintenance means embracing adaptive approaches, prioritizing quality over frequency, making data-driven decisions, leveraging predictive technology, and focusing on prevention to maximize both performance and cost savings. Direct injection engines are prone to carbon buildup on intake valves, which can significantly reduce performance and fuel economy. Professional carbon cleaning services can restore lost power. Here, you can see the dramatic difference carbon buildup makes. The dirty cylinder shows heavy carbon deposits that restrict airflow and reduce compression, while professional cleaning can restore the engine to near original condition. High-quality fuel system cleaners containing polyethyramine, or PEA, are highly effective at removing fuel injector deposits. Modern PEA-based cleaners show 40 to 60% better deposit removal compared to traditional additives. Look for cleaners specifically containing PEA, as they provide superior cleaning power. Regular use every 3 to 6 months can maintain optimal fuel system performance and prevent costly injector replacement. The Italian tune-up is a time-tested method where you drive at high RPM for 15 to 20 minutes to burn off carbon deposits. This works because temperatures above 2,000 degrees Fahrenheit help oxidize carbon buildup. Watch as we simulate the RPM increase during the Italian tune-up. This high RPM operation creates the heat necessary to burn off carbon deposits and can restore 5 to 10% of lost power in moderately affected engines. Oil analysis is a game-changing maintenance technique that can extend oil life by 50 to 100% while maintaining full engine protection. Laboratory analysis of used oil determines the optimal change interval for your specific driving conditions. According to industry data, 73% of engines analyzed could safely extend their oil change intervals by 2,000 miles or more. This represents significant cost savings while maintaining optimal engine protection. Upgrading to premium synthetic oil provides significant efficiency gains and longer drain intervals. While premium oil costs about 40% more, it typically lasts 100% longer, making it more cost-effective overall. Premium oils also provide better protection in extreme temperatures, reduce friction by up to 15% with nano-lubricant technology, and help prevent engine wear. The investment in quality oil pays dividends in engine longevity and performance.